Hi, this video is about the relative airflow through the auxiliary air valves of the different types. You might remember that there are three designs of the shutter. One is this triangular design, the other one was the sort of bent oval with a flattened top, and the last one was once again some oval shape with a little cutout on the side. And all of these, as they close, must have different airflow characteristics, shutting it off earlier, quicker, that sort of thing. And I'm trying to figure that one out in this video. So relative airflow, because I cannot say anything about absolute airflow in that would be speed times open area, would give me liter per second. And if I do density times speed times area would give me kilogram per second. Either one will not be accessible through what I'm doing. So at this point the only thing we are getting is the area, and under the assumption that they are subjected to the same airspeed or speed of air going through, then we can easily compare them, and that's what I'm going to do here. There will be a later video with absolute values, because to do that I need to run a car and measure the RPM at the same time as the vacuum in the intake manifold. But then I should be able to get actual air volume per second values. But as I said, this one here will just be a comparison between the three. To get an idea about the airflow, I have now come up with these little models. I put the shutters on the scanner and then magnified them about 7:1, and this is what came out of it. So this is the shape of the air gap of version 1, this is version 2, and this is version 3. I only have at the moment auxiliary air valves with version 3 and version 1. I do not have any of those. But I'll do the measurement anyway, and what I'm going to try to do is the following. I here got that gap in the auxiliary air valve, which is an ellipse, long axis 14 mm and short axis 7 mm. And what I'm going to do is this. I'm going to put a little pin through here. And here. And then I should be able to see my auxiliary air valve fully open. And then slowly close. And then I can correlate that with the angle. The problem, of course, is the shape. And especially these round shapes here. I do not see any chance of capturing that mathematically. At least I have no intention to do that, even if it would be possible, but it's way beyond my mathematical abilities. But instead of doing an integration, I'm just gonna do a graphical integration, and that is an old trick. What you need for that is what I would basically do is I have this now fully open, and then I'll adjust it a certain number of degrees, maybe, I don't know, 5, 10, 15, 20 and so on, and then every time make a line along this edge. So I can then determine at what angle how much of this gap is still open. And instead of doing some weird piecewise function and integration, which would, I don't know if I would ever be able to do it, but it would certainly take weeks for me, I will just do it graphically and with a little scale. So the way to figure out these weird
these weird shapes and their area. The trick is using a milligram scale. So this measures down to 1 milligram, and as I put those lines on here, I just cut off one after the other and measure the remaining remaining area, which gives me the open air gap. And then of course I have no idea how to measure the area of that thing. So what I'm going to do is, as I said, old trick. I have not invented that. I'll just assume that all my manila folders have the same thickness, and so the same weight per square centimeter or square millimeter. And then I will just do something like, I don't know, 5 by 5 centimeter a square. That is something I do know the area of. And then I weigh the remaining bits here against those 5 by 5 centimeters. And that should be should give me basically a graphical integral of that air gap that is being closed. Okay, I now have marked all my overlaps at different angles on all 3 versions of shutters, and I realized something. It appears that the room temperature value for all of them is roughly about 30 degrees. So if I look at an auxiliary air valve at 30 degrees, I see about this. And the same is true for version 3. Where I do see something like this at room temperature. So once again, this would be the visible opening at room temperature. And that, since it's both 30 degrees, I think I can now postulate that this is likely the same for version 2, which I do not have. But I hope that I'm not mistaken with the assumption that you would also have to see 30 degrees, and that would be something like this. And once again, this being the light gap. So I hope that's true. I don't know. If anybody has one that still works, you might want to double check that, but I think since they are internally pretty much all the same, that this is likely to be true. So next step now is to cut all these up and then determine the weight of each of the slices. Not of the slices, but on the remaining part, you do want as much weight as possible. There's an old saying that in order to determine the weight of the captain of an oil tanker, you do not weigh the oil tanker with and without captain. So this is what I'm trying to say here. It's going to be a bit tricky because when I am at 40 degrees, I have this here that is getting smaller and smaller, but this part is getting larger and larger in the beginning. This little corner here is not open, so there's my little pin. There we go. So what I see in the beginning, when I pull this one particular out of the freezer, I see this, and so now this part is being diminished, but this one grows until 35 degrees. So I have to figure out how I do that, probably just by either marking each piece that I cut off, or make a copy and do the same thing again and then measure what I take off, what is added on each side. I'll see. But next thing I will present results. This is my my reference piece. I do have 50 by 50 millimeters, 2500 square millimeter, or 25 square centimeter, or 0.0025 square meter, and I have a weight with that which is 458 milligram, and it showed 458 milligram repeatedly. Also, this will then have to be calibrated by the magnification factor, which is 6.857, and since it's an area, it has to be divided by 6.857 squared. But anyway, I now know that 25 square centimeter weigh 458 milligram. These are the results of my measurements on the models. This is for version 1, 2 and 3. Version 1 being the blue curve, version 2 being the red curve, and version 3 the green curve. The numbers on the left are actual air gaps in square millimeter of the actual or original auxiliary air valve, not the models. The model numbers would be probably roughly 49, so the scale was 7:1 roughly, so it would be 7 square 49 times larger. So these are the square millimeters of the opening in the actual auxiliary air valves. What you can see is that the version 2 and 3 have a high initial opening of between 65 and 70 square millimeter, while version 1 only opens 43, I would guess 43 square millimeter. This tells me that if you are ever in a position where you have to replace one auxiliary air valve that you cannot get anymore with another one that you might be able to get, it would always be best to replace anything version 1 with 2 or 3, because if you do it the other way around, if you have a car with a version 2 or 3 and then you put a version 1 auxiliary air valve on it, you will have too low airflow in the beginning when you have cold start, and it's very likely that this will also have give you trouble during warm-up. I do not truly know this, but this is what I would assume based on the function of the air valve. The auxiliary air valve version 1 is going down pretty linear, while version 2 is going steeper, but seems to have two distinct regions where the valve closes fast and then slower, and version 3 comes straight down and then curves into the closed position. Okay, these are the same data, but I have normalized them to the 7-degree point. So I adjusted them in a way that they are all showing the arbitrary number of 1 at 7 degrees. And the scale is different, of course. I should have mentioned that before. I'm now going from fully open to close, so I count the angle the other way around, because otherwise the curves would be increasing, and it feels wrong to me. If something gets smaller, I want to have the small value on the right and the large value on the left. Anyway, so what used to be 47 degrees is now 0 degrees, and what used to be 0 degrees is now 47 degrees. But that's just a way of presenting the data. What you can see is that they behave very differently. For example, 1 and 2 come out of the y-axis almost horizontally and then curve down. So this will point to an initially large air gap that is being kept large and then goes down in a different way. Once again, you can see the green curve just going smoothly down and going into the going down to 0, while it's very obvious that the version 2 has these two distinct regions in terms of slope. So that would mean you have an initially large air gap, it's being kept, then it goes down, and then while the engine is warming up, it's being kept open a little longer than the other two. The 2 and version 1 and 3 mostly differ by the slope, and also by that version 3 starts at fully open valve and goes straight down without any hump like the other two do. So as I said, I think pretty much they are all equivalent, but there is some fine-tuning in what the opening, the actual air gap is over the rotational angle. But from the absolute values, as I said, I would think that you are probably going to be able to replace a version 1 with 2 and 3, but not necessarily the other way around, because version 1 would not give you enough air gap for cold start and warm up. Thank you for watching.